Welcome to the ARD and Regen troubleshooting class. I've gotten a lot of requests on my channel for a more in-depth Regen troubleshooting video other than just my ARD head one. And I get a lot of questions about these engines, which were the last model engines that CAT ever built. And they were available in C7, C9, C13, and C15. Now these systems are very hard to troubleshoot, and it's hard for me to say in a comment section of a video how to troubleshoot them properly. So I decided to make this lengthy class. Now originally I was going to charge for this class because it took me a lot of hours to build this class and edit it. And I posted the video to YouTube, and after a couple minutes I took it down because I don't want to charge for the classes. If you would like to help support the channel on PayPal, the name is adeptape@yahoo.com. I've gotten 3 donations this week. One from John for $50. Thank you, John. One from Carlos for $30. Thank you, Carlos. And one from Craig for $25. Thank you, Craig. And these help to go on supporting the show. Without further ado, I present to you the Regen and ARD troubleshooting class. Thanks for watching. Alright, so let's get the format of the class out of the way. First part, I'm going to be talking about terms and terminology in the system, and there's a lot of confusion about like what's an ACERT engine, what the Regen system does. I'm going to be talking about that. The second part, I'm going to be talking about the components, their locations. Then I'm going to be going into the troubleshooting, and I'm going to be going by not component by component but system by system, because there's several systems in the Regen system. And if you have any questions or comments throughout the class, you can leave them in the comments section and I'll try to answer them as quickly as possible. Now also, when troubleshooting Regen systems, we're going to be using CAT ET. That's really the only software you're going to be able to use. If you have a scanner or a code reader that isn't CAT ET, it's really going to prevent you from doing a lot of the code clearing. It's going to prevent you from doing a lot of the data log and the testing that only CAT ET can use. So that is unfortunate, but you know, CAT designed this software, and most of the emissions stuff, you know, even if it was a Cummins or something else, you have to use the dealer software. It's really hard to use some sort of aftermarket software. Okay, so let's get on to component identification and explanation of the ARD Regen system. Alright, before I start showing you the components and their locations and what they do, we need to discuss some terminology. So the first part is ACERT. CAT has used this from the mid-2000s on their truck engines to describe their somewhat emissions-related engine technology. Now this term came about before the Regen system. So I hear a lot of people say, oh, it's an ACERT engine. And what they mean is it's a Regen engine. Well, that's not accurate. So the C7 engines and the twin-turbo C15s and the twin-turbo C13s were also ACERT engines. Now, that didn't mean that they were Regen engines. That just meant they had some emissions-related technology to them. But they did not use a DPF, they didn't use an ARD head. So if you hear ACERT and someone's referring to it as a Regen engine, that's not entirely accurate. Now, Regen engines are ACERT engines, but not all ACERT engines are Regen engines. Does that make sense? So a 2005 C7 would be an ACERT. Also a 2009 C7S with a Regen would be an ACERT engine. But that doesn't mean they're both Regen systems. Okay, so I just wanted to get that out of the way. Also, the CAT Regen systems has nothing to do with DEF or diesel exhaust fluid. The Regen systems are strictly preventative of diesel particulate, meaning black smoke. Now, the black smoke is not a global warming, increasing particle. It's not like the DEF systems are supposed to prevent nitrous oxides. So that fluid on a DEF system it injects a diesel exhaust fluid, which is urea, and it's supposed to prevent nitrous oxides. Now those systems also use a DPF, but CAT never used their DEF systems for nitrous oxide reductions. They didn't use a DEF system at all. They only used the DPFs, and that's pretty much only to prevent the carbon or the black smoke coming out of the exhaust. So this DPF system is only to prevent black smoke from coming out of the exhaust, basically. Okay, now what engine model serial numbers used the Regen system? So these are the full Regen engines. On the smaller engines, the medium duty as they're called, your serial numbers will be a C7S and then the 5-digit numbered code, or a C9S. Now a C7S is a C7 Regen engine. C9S is a C9 Regen engine. On your heavy duty, you had a C13 Regen engine, which would be an LEE, Lima Echo Echo, was the abbreviation for a C13 Regen engine. On the C15, it was an SDP, Sierra Delta Papa. Those are your C15 Regen engines. These were the only serial numbers that use the Regen systems on the CATs, and they were basically in production from 2007 up till 2010. Okay, that's basically the terminology that you're going to be needing to know. I'll be going over what the acronyms mean as we go system by system, but those are just the big terminologies I wanted to get out of the way to start the class. Okay, so if your exhaust stack has this coming out of it, which is black smoke, that means you've got unburned fuel. And this is what the DPF is meant to prevent. Any unburned fuel or carbons are going to be trapped by the DPF. That is the DPF's job. It's to stop any black smoke from coming out of that stack. Doesn't help with CO2, carbon monoxide, anything else. So here we have a Dpf setup. This is a single Dpf. If you have a heavy haul truck, it might have two Dpfs, but that's very rare. So a Dpf is also typically your muffler, and you have an inlet and an outlet, and a Dpf Sensor Box, which we'll be talking about later. Now what's in the Dpf? In that center section, this is a close-up of what the Dpf, basically the honeycomb, looks like. And it's called a honeycomb because it's a series of very small channels that, if carbons are trying to go through it, will typically stick to it. And over time, it'll turn into that. It'll get caked with carbon. If you have unburned fuel or oils getting in that DPF, it'll get plugged. And when it gets plugged, it's the same thing as having a plug muffler, and it needs to get rid of the carbon stuck to it. And how do you clean out a dirty DPF? Well, fire, or actually heat, to be more precise. Alright, so as you can see, the inlet side of that DPF is going to get plugged over time. That's normal. Now that plugging there is obviously excessive, but it's going to plug over time. So how do you get rid of the carbon and the unburned fuel and the oil that gets stuck on the inlet side of the DPF? Well, it needs to regen, and that's what the purpose of this video is really about, is the Regen system. And what it needs to do is it needs to turn the soot that has accumulated on the inlet side of that DPF, well, it needs to cook it. And basically then it turns it to ash and decreases the volume of the soot to ash. So it has to do a regen. And what's a regen trying to do? Well, it's trying to get that Dpf inlet temperature up to just under 1100 degrees Fahrenheit. So typically your ECM is looking at the Dpf inlet temperature, and it usually wants it to get around 1085, 1086, something like that. Once it gets to that point, that means that the soot is successfully being burned and it's cleaning out the DPF. Okay, let's talk about some other components. Alright, so we have a C15 regen engine here with an SDP serial number. And what we have here is your control valve for your secondary air circuit. Now I'm going to be talking about the secondary air circuit in just a little bit. And here's what you need to know about it. For starters, there's one sensor that measures the volume of the secondary air circuit, and it pulls fresh air off of your boost system. And that sensor has two small air lines that run to it that it measures the pressure for. But I'm going to talk more about this first. Okay, so I was talking about the secondary air system there and showing you some of the components of it. And now I need to explain what they do. Then I'll talk about the yard head, what it does, the fuel system, how it affects the yard head, the DPF, how it affects it, and then we'll go into troubleshooting as the end of the portion. So, secondary air system. In order to have combustion, you need an air and a fuel mixture, right? So you got air and fuel, and on the yard head you're also going to have spark, which we'll talk about later. So, air, where does it come from? Remember, the yard head is on the exhaust, so there's no fresh air to it. So what we need is fresh air to be supplied to the yard head in order to combust the diesel fuel that's getting sprayed by the yard head. So we're going to talk about the secondary air circuit. It's a very simple system, but it can cause problems with your regen system. And here's why. Okay, it pulls air after the turbocharger. So this is boosted air, higher than normal atmospheric pressure air, because it's been boosted by the turbocharger. When that control valve that I just talked about, or showed you in the clip, opens, which is controlled by the ECM, it sends air to the yard head. Now that valve's only open during regens, or if you're doing an air system verification test, which is a test that is used in order to troubleshoot the regen system. So, what you're looking for in your secondary air system is you need to have some boost, and you need to have some volume of airflow going to that. Now later when we're talking about troubleshooting, I'll show you what is an acceptable volume of air. But just know this, the secondary air system sends fresh air after the turbocharger to the yard head, and that is in order to allow the yard head to mix the air with fuel and have combustion. Okay? Now I'm going to be moving on in the video clip. So our next component is the yard head. In the center you have your heated nozzle circuit, you have your yard flame temp sensor, you have your spark plug wire and spark plug. Then you have 4 lines going to the yard head, all in close proximity. The bottom 2 are coolant lines, and then you have a main and a pilot line. So bottom 2 are coolant lines, main and pilot fuel lines. And this is an yard head. They cost about $1,000. So if yours is bad, that's what it's going to cost you. That's just the part price. Weigh about 5 pounds. Not a whole lot to them. We're going to be going over the components that connect to them. The first 2 fittings you're seeing, you have 2 fuel lines. There's a pilot and a main fuel line. Below that, there's 2 coolant lines that run to it. And this is a antifreeze cooled head. So here's it installed. You have your pilot, main, and your coolant lines. If you remove the head, you're going to have to drain your coolant, or else it'll dump all the coolant out of the engine. This port here is called a secondary air port. This is fresh air fed to that to help ignition. That is your port for your yard flame temp. Here's kind of a crappy picture of it. So the tube on the top, secondary air, and then you have your yard flame temp sensor going into it. The top part is called a heated nozzle connector. If it has a C11, C13, or C15, you have that top port. And right there where there's a blank, if you have a C7 or a C9, you're going to have a purge air. Now this is off a C15, so it has this heated nozzle port, which is a electrical connector that's supposed to keep the head from purging. So we have a heated nozzle. This is on a C15. And there's no purge air line. This is a C7. There's no heated nozzle line, but there is a purge air port. So, going from that, we have a spark plug. yes, your diesel engine has a spark plug, but that is just to ignite the fuel-air mixture. And you can see the gap there. The gap is set by the head, not by the spark plug. The spark plug, which is a cat-specific part, is just a long electrode. There's nothing to adjust. There's no spark plug gap. There is one problem, however, with this. The metal tang that is in the art head, on some failures, that tang will actually distort from all the heat. And you see that little gap? Well, sometimes it'll touch that spark plug, and you won't get any spark. That'll cause it to not regen, and that'll shut you down because your DPF will fill with soot. And then right in the very tip is the actual nozzle. Fuel just sprays out of the tip there, nowhere else. And that is pretty much all the components you need to know about the art head. Okay, so that previous clip was from my art head video that's already on YouTube. And I wanted to include that because that's what the art head removed. And those are basically what I already showed you with the art head installed, but it's nice to see it with it removed. Now, when we're going through the troubleshooting portion later in this video, it's good to remember that the art head is going to be the cause of failure on the vast majority of your regen issues. Probably about 80% of them are caused by the art head. So if you're having a regen problem and that art head hasn't been changed in at least a year, it probably is going to need an art head again. Now the downside of that is the art head is very expensive. You're looking at a little over $1,000 if you're getting it from a cat dealer. And then, you know, some labor to change it out. Now you can do it yourself. The only problem is you typically can't clear the regen codes if they've logged hard, meaning it's got a loss of combustion, or a failure to ignite code. Those have to be cleared with a factory password, which if you're not a cat authorized dealer, you won't be able to get. So that's the components you need to know about the art head, and I'm going to be moving on to some of the other components in the regen system. Okay, so moving on after the art head, where it's bolted to the combustion housing, we have what looks like to be a small flange. Now this flange is not just a gasket, although there is a gasket under this and under the art head. This is called a combustion canister. Now the one on the top, as you can see, has a broken bottom portion. That's because on the older combustion canisters, there was a welded plate on the bottom of them that can break off over time and cause the system not to regen. The newer updated ones is rounded, as you can see on the bottom combustion canister. The downside of this is the updated one is very expensive. This combustion canister is around $500. The reason you need the canister is because the fresh air and the fuel need to mix outside of the exhaust stream. So if you're doing an art head, it's a good idea to pull a combustion canister out and take a look and make sure the bottom hasn't fallen off, and hopefully it has the updated combustion canister. And that's really all you need to know about the combustion canisters. Okay, so that's really the main portions of your regen system. Next I'm going to be showing you kind of some of the parts of the DPF, but we'll be going into that a lot more thoroughly later in the video when we're talking about the troubleshooting portion. So your DPF, you'll have two lines going to it. One of those lines is a CGI system, which we'll also be talking about. So the exhaust stream comes in hot, then goes through the center section, and then goes out the other end. So here's your Dpf Sensor Box. If you have a Dpf Sensor Box code, the sensor box is one part number. You unfortunately cannot change it. On the inlet side of the Dpf Sensor Box, you have a temp sensor, Dpf in temp sensor, and you have a Dpf outlet temp sensor, and then the two tubes going to that sensor box are your Dpf Differential Pressure sensor. Okay, so here was one where I was changing an art head. If you do end up doing an art head, they're very easy to change. You're supposed to change the nuts going to them, so you'll have 5 new nuts, the art head. I always also change the spark plug. Every time I haven't changed the spark plug to save the customer the $20 or so that the spark plug costs, I end up regretting it because typically the spark plug will have failed or the tip will break off. So if you're going to change your art head, it's a good idea to go ahead and change your spark plug. Also, as I already mentioned, the art head has coolant going to it with 2 lines, so if you're going to change your art head, it's a good idea to drain the coolant first. You can cap the lines quickly, but it's really hard to do that usually fast enough, and it makes a big mess. So I drain the coolant system if you're going to do it. But anyone can change an art head. The changing of the art head. Now on the intake side of your engine, there's also some components we need to talk about. And the first is your fuel enable valve, which is right there. And then there are some other valves. And then there's some other components on this side. In your rear fuel manifold, you're going to have 2 sensors, your pilot and main pressure sensors, but you're also going to have 2 valves that might play a important role in your regen system if you're having regen problems. And that's your pilot and main control valves. And I'll highlight them here. These are what control the amount of fuel that go to your art head. That's your pilot and main control valve. Alright, so hopefully this isn't getting a little overwhelming with the amount of components that tie into this regen system. But there's a lot of systems that tie into this regen system. That's why I made this long class, because some people, even mechanics I know, when a regen problem comes in, they just say, oh, it's a regen problem, it's an art head. And you know, 75 to 80% of the time, they're right. But what about the other 20 to 25% of the time? Well, that's when this comes in handy. Knowing all the systems and all the components and how they tie in. So let's talk about the regen fuel system, which is pretty boring, but it ties in with your ARD system. So we already discussed the air system. How about the fuel system? So where the ARD head gets its fuel from is the same place that your engine gets its fuel from. Your fuel transfer pump pulls fuel from your fuel tanks through the filters, and it then pumps it under pressure to your cylinder head. Well, before it gets to your cylinder head, there's a line that comes off of your secondary fuel filter, which is the one mounted on the engine. What happens is, when the ARD system needs to engage, that fuel enable valve, which is the first valve I showed you, will switch on. Now what that does is it diverts some of the fuel that just gets pumped to the head, it diverts some of it to the rear fuel manifold. Now the rear fuel manifold controls your pilot and your main control valve. There are 2 valves there. They also cannot be swapped. They're different. And then the pilot and main control valves control the amount of fuel and fuel pressure that gets sent to the ARD head. Now, why are there 2 fuel circuits? Why is there a pilot and why is there a main? Well, from the names you might think that the pilot valve only lights the ARD head and then the main kicks in and does all the work. Well, that's wrong. In fact, I don't even know why CAT has a pilot and a main, because the pilot pretty much does all of the work. The main only kicks on typically if you're having regen problems and the pilot's maxed out. But typically if your main's coming on, that means there's already a problem with your ARD head. The pilot does almost all of the work. In fact, if you see the main coming on, you probably need a new ARD head. So, your ECM controls your fuel enable valve to kick on and off the pressure to your pilot and main, and then the pilot and main divvy out the pressure to send to the ARD head to control the amount of heat that's getting to that DPF. Okay, I'll show you a fuel diagram, and I'll show you kind of what pressures we're talking about. Now, know that the pressures going to the ARD head are much higher than typical fuel pressures on a CAT engine. Typically on a CAT engine, the fuel pressure that gets pumped to the head is, on a C7, it might be, on an older C7, because the newer C7s, The newer C7s don't pump fuel to the head, they pump to the high pressure fuel pump. And that pressure is not very high. You're talking 70, 80 psi. On the C15s, you might get up to 100 psi. Well, the fuel pressure that can get pumped to the art head is much higher. You're talking, anywhere from like 250 to 280 psi. So how does it divvy up the pressure? Well, I'll kind of show you in a fuel diagram how it does that, and it's kind of complicated, and it relies on a lot of check valves and pressure regulating valves, okay? So let me show you a picture, and I'll kind of talk about that. Okay, so here's my hand-drawn, obviously, fuel diagram to explain the system. So starting at the fuel tank, runs to your primary fuel filter. From your fuel filter, it runs to your fuel transfer pump. After the fuel transfer pump, it is under pressure. It runs to the fuel enable valve. Now this is where the art head system kind of starts. So from the fuel enable valve, there are two options for where the fuel runs. Now in normal mode, the fuel runs just through the enable valve, then through your secondary fuel filter and to your engine. Now when the fuel enable valve kicks on, what it does is it bypasses the fuel from its normal route and sends it up to a pressure regulator. I know that looks like an A, but that's a U. I know how to spell regulator. So it runs it from your fuel enable valve. I really wish this paper would stay still. So it runs it from the fuel enable valve up to a T, which has a pressure regulator, which then bumps your pressure from the normal, 80 to 100 psi, all the way up to about 280 max psi. So that way you have 280 psi or around there going to your pilot and main control valves. And then since the pressure regulator is before your main fuel line area, you have only the normal 100 psi or so of fuel pressure going to your engine. So diverts it from the normal route. It goes to a pilot and main control valve, and then you have a pilot and main sensor. The V is the valve, so the valve is before the sensor, and that's your basically ARD fuel system. So after the pilot and main control valve, it goes pretty much straight to the ARD head itself. And that's really the fuel system you need to understand on the regen systems. And the system's pretty much the same on the C7s, the C9s, C13s, and C15s. And that's really what you need to know about the fuel circuit on these regen systems. Okay, so now you probably understand a little better how the fuel circuit works for the regen system. So that pressure regulating valve, depending on if it's a C13 or C15 or C7 or C9, that is engaged when the fuel enable valve kicks on, it could be 160, 180 psi pressure regulating valve. So why is the pressure higher than that? Well, remember that there are other pressure regulating valves in that fuel system, and depending on how many that the fuel has to go through determines how much pressure. So if you check your fuel pressure on your secondary fuel filter, and let's say it's a C15, normally it's around 100 psi. Let's say it's low, let's say it's at 40. That means that the engine fuel pressure regulating valve, which is in the fuel filter housing, is probably bad. Or you might have a bad fuel transfer pump. But if that pressure regulating valve that's for the engine is bad, that will drop your ARD fuel pressure as well, because it's not only relying on that valve that it has to bypass for the ARD system, it's also relying on the end valve. So the pressure is going to be that 160 psi check valve plus the 80 psi or the 100 psi pressure regulating valve that's in the fuel filter base, because the fuel pressure, it has to go through each resistance point, so it'll be the cumulative of all the pressure regulating valves. So remember that if you're, if you have other fuel issues and your engine's not running correctly, that doesn't mean that you necessarily have an ARD problem if you're not regenning. It might be engine related and you might have a fuel pressure issue. So other things that can cause fuel pressure issues, plugged fuel filters, things like that can affect your ARD system. But typically a regen system problem is not caused by low fuel pressure, but we'll be talking about what pressures look good and what don't later in this video. But for all you need to know really is that's how the fuel system works. So now we need to talk about the placement of your exhaust gas temperature sensors. And there are 5 of them on a regen system, so you need to know where they are, and there's a couple different names for them. So what we have here is, you can see the exhaust flows this way. We have your turbocharger, your ARD head, and your DPF. And your first sensor is your turbo outlet temperature, also known as EGT1. Then you have your EGT2, which is ARD flame temp, and that is inside the ARD head itself. Then moving on is your ARD outlet temperature sensor, also known as EGT3. This is typically a foot or two away from the ARD head, downstream from the ARD head. Then you have your Dpf inlet and Dpf outlet temperature sensors. So Dpf in, Dpf out, and that's in that sensor box. Now your sensor box also has your Dpf differential pressure, which runs 2 small tubes to the inlet and the outlet of the Dpf. And that's pretty much all you need to know about your temperature sensors and their locations on your ARD system, and this applies to all Cat regen engines. Alright, so next I'm going to talk about the spark system, which very rarely has any problems. But if you're in Cat ET and you go to Engine Diagnostics and then go down to System Troubleshooting Settings, there's something called a ARD ignition transformer primary status setting. Now if you set that with your engine off to override, you'll turn on that spark system. So it's currently off because the engine's off and it's not running. Now what you can do is put a normal spark checker, similar to any automotive spark checker, in line with the spark plug wire, and when that circuit is turned on, see, you have spark. And as long as you have spark, that system is working normally. Alright, now I'm not going to spend a lot of time on the ARD spark system because there are really not that many issues with it. It's a very simple setup. There's a small transformer that sits on the exhaust side of the engine, bolted to the engine, that's controlled by the engine ECM. And then it is a single spark plug wire that runs up to the ARD head, and it fires that single spark plug. If you do that test in ET for the ignition primary status and turns on with your spark checker and you have spark, the system's working. It's very rare that that system is causing an issue. I have seen where the spark plug wire is bad and it's grounded. The transformers very rarely fail. If you're not getting spark, but you can hear it arcing internally, like the spark plug wire is bad, also check your spark plug gap on the ARD head, because as I said before, that gap can close, because if your gap is set by the spark plug and tying in the ARD head, if that gets too close, it'll touch and you don't have spark. That can cause a failure to ignite code, and your regen system won't be working. And that's pretty much it on the spark system for the regen system. Okay, so this portion of the class is the last portion of the class, but it's going to be the longest portion, and we're going to be talking about all the principles we just went over and how they apply to causing a regen problem. Now, to preface this, I'm not claiming to be the best cat mechanic ever to walk the planet. However, I am a very good regen troubleshooter. I've troubleshot hundreds of regen codes over the years. I know what I'm talking about on these systems. So if you have an issue, you can leave a comment in the comments section if you're having a problem. Rewatch the video on things that you've had trouble with. But I'm going to be going over how I troubleshoot the regen systems and how I think it is best to troubleshoot the regen systems. Now if you go through the CAT, sys troubleshooting, you know, it might be different than how I do it. This is just what works for me, and I think everything I do makes sense. Now, obviously, you can do it however you want, but if you're taking this class, please do it the way I do it. I think my way works the best, at least for me, and I have success with troubleshooting regen systems, okay? So let's get on with troubleshooting regen systems. Alright, so troubleshooting regen systems. We're going to be using cat ET here, and we're going to be doing data logs and looking at data logs, and also doing manual regens and then analyzing them. Now, if you're troubleshooting a regen system, you pretty much have to use cat ET. And the reason for that is the codes are going to lock you out if it's a hard code, meaning it needs a factory password to clear it. If it has a hard code and it needs a factory password, you won't be able to do any regen attempts until you clear it. Also, using cat ET, if you're not familiar with doing data logs, I'm going to be talking about that a little bit, how to set it up, and then how to view it. And then it's just basically looking at graphs and looking for, well, basically what you're looking for. Now, the three principles of regen troubleshooting are fuel, air, and spark. Same as with combustion. Now, it's not exactly that simple because your secondary air supplies the air, but things can affect your secondary air, or it can affect your successful regen without really throwing a code. So, first thing I want to talk about, and then we'll go on to the data log recording, is your Dpf differential pressure. The first thing I always check if you have a regen problem is your Dpf differential pressure. Is it high? Now, high differential pressure doesn't always throw a code, and it's kind of subjective. What is considered high? If you're doing a regen and it's over 1 psi, meaning you're doing a stationary regen with the truck just high idling, and your Dpf differential pressure is over 1 psi, that's kind of high. As it climbs in differential pressure, that means that Dpf is plugged. And if it gets too plugged, that can prevent secondary air from getting to that art head, because you have only a couple pounds of boost trying to push air into the art head. And if you have a high differential pressure, it's not going to be able to overcome the differential pressure. So that's always the first thing to check, is your Dpf differential pressure. If it's really high, say it's over 2 psi or something, well, that Dpf is going to have to be removed and cleaned first. Also, if it's highly plugged, that's going to restrict the amount of boost, because you got air going into the engine, but you don't have as much coming out of the engine. It's the same velocity because it has to go through the Dpf. Other things to look for that might throw you off really quickly. Before you start the regen, what are the temp sensors saying? Is one of the temp sensors in the exhaust stream? You have your art flame temp, your art outlet temperature, your Dpf inlet temperature, your Dpf outlet temperature. Are any of those really far off from one another? If your Dpf inlet and your Dpf outlet temperature, well, with the engine just running, are off by 400 degrees or something, you have a problem with the sensor. So those are things to look at. Alright, now we're going to be going into data log recording and what to look for. Okay, so what we're looking at here is the status screen in cat ET. And you can see we have 2 active events, and we're going to be finding out what those are and then troubleshooting those. Now, this truck came in for regen problems, so you're going to go up and click on active events, and it'll show you what they are. So we have Aftertreatment number 1, loss of combustion, and Dpf soot loading percentage high, moderate severity, and the occurrences. Now, these are active, so the occurrences don't really matter that much because they're active. They need to be troubleshot. Now, the soot load can't be cleared. That has to be cleared by doing a regen, but the aftertreatment can be cleared. So in order to do a regen, we're going to have to clear that loss of combustion code, because that is a hard lock code and that will keep you from doing a regen. So what you're going to do is go down and reset all, And what that's going to do is it's going to try and erase that after treatment active code. So when you hit reset, this prompt is going to come up because it's going to require factory passwords. If you don't have factory password authorization, you're kind of stuck here. You cannot clear that code. So in the green box, that's where you have to input your factory passwords, and on around the yellow, that's a hyperlink. If you click on that hyperlink, it will send you to Cat's password website, and if you have factory password authorization, you can enter your information there and it'll give you a factory password. So if you successfully do that, it will clear the code. So that's cleared, but the soot loading only clears with a successful regen, remember. Okay, so before we do a regen, we need to start a data log. So if you go up to information and then go down to data log, then recorder, we're going to set up a data log. And you're going to set this to 20. You're going to set the duration to, I typically set it to 90 minutes, but you can set it to an hour, whatever you want. Pre-trigger should always be 0. And then you need to click add. And what you're adding here is what parameters you want the data log to record while you're doing your regen. So if you're doing a medium duty, that'd be a C7 or a C9, you would do those parameters. You might want to write those down. If you're doing a heavy duty, which would be a C13 or C15, you want these parameters. And this is a C15, so we're going to do a heavy duty regen. Click OK. Then you click OK. Looks like you have everything set up. Now the sample rate needs to be 20 or less, because if you don't set the sample rate that low, you can't leave the data log screen. So this is armed, but it won't start until you go down and click start. Make sure you click start, and then it'll start counting down. You can see the timer there is now counting down. So now we can try our regen attempt. So you can leave this screen, and you're going to go up to service, service procedures, and then manual DPF regen. You only do an ash service if you're taking off the DPF to get cleaned. If you just want a normal regen, you're going to do a manual DPF regen. It's going to come up with a prompt telling you that the exhaust gas is hot. Yes, we know that. So now this is a stationary. You typically do this with the truck not moving. Those are your parameters that need to be all within, or it won't start a regen. So no vehicle speed, and coolant temp needs to be above 140 degrees. So in this screen we're looking at, so we're at 144, so it'll start. We still have our active events. You're going to click next, and you should have a check mark. Okay, engine must be running. It's going to tell you that it's going to ramp up the speed. On a C13 or C15, it's going to ramp it up to 1400. On a C7 or C9, it's going to ramp it up to 1200. So you can see your engine RPM slowly increasing, and it'll take it up to 1400 RPM. Now, what it's doing now is called pending checks. What it's doing is it's testing the secondary air circuit and the pilot fuel system circuit. So if you look at your hard flame temp, it's actually dropping slightly. And the reason it's dropping slightly is because during the pending checks, it opened your secondary air valve. So you have fresh air going into the ARD head system. Now we're in ARD ignition. What we're looking for is a quick increase in the ARD flame temperature. So watch that. Okay, it just jumped up to 208, 205. And what it did is it obviously ignited because you had a quick increase in flame temp, but it lost combustion quickly. So this is going to fail. Failed after treatment loss of combustion. Now, it will not hard log that code until it does it a few times, typically 3 to 5 times. Once you do multiple attempts and you keep getting that after treatment loss of combustion code, it's going to hard log it before, and then you'll have to get factory passwords to clear it again. So we've done it once, and it failed. It ignited and then immediately died. So what we need to do now is view the data log. So we're going to go back to data log, click on recorder, and we can stop the recording. So go down to stop. It'll stop the recording. And then what you're going to do is go to graph. And this is where you're going to be looking at the graphs that are going to show you, what was going on in that region. So if you go up to browse, that's just going to show you all your files, but it should load the latest one. So typically on a loss of combustion, it's normally an ARD head. Your spark system's working or else it wouldn't ignite. If many of the other systems are way out of whack, it wouldn't ignite either. So usually means your ARD head is spraying in a weird fuel pattern. So what we're going to do is look at our ARD pilot pressure, just to make sure it's getting good pilot pressure, and the Dpf differential pressure. Because Dpf differential pressure, if it's too high, can cause issues. It typically won't cause a loss of combustion, though. So we got our lines here. You can see the red is ARD pilot fuel pressure, and Dpf differential pressure is the blue. You can set your min and max to kind of give you the range you're looking for. So on the right where that red spike is, that's about 100 psi. And that's good. You want 100 psi during ignition attempt. Now the blue is your differential pressure. And that is around, what's that? About 0.4, which is acceptable. That's perfectly fine. So looks like you have good differential pressure and good pilot pressure. So next thing you want to do is make sure your secondary air circuit is working. And the best way to do that is to go up to Diagnostics. Then you're going to go to Engine Air System Verification Test. It's going to give you all these warning prompts. And then it's going to run through this little test. And depending if it's a C7 or a C15, it's going to have differing amounts of statuses. And I'm going to talk about the statuses right now. Okay, so when you do your air system verification test, it's going to give you either 4 or 6 test points and numbers associated with them. If it's giving you 6 test points, that means it's on a C7 or a C9. So this is obviously a C7 or C9 because we have test point 5 and 6. Now, I'm not showing test points 1 and 2 because those don't really tie in with the regen system. What those are CGI test points, which CGI is clean gas induction. That's like your EGR. And CAT has almost no problems with their CGI systems. Very rare to have problems with their CGI system. The only thing I've ever really seen is the CGI differential pressure sensor go out. But other than that, they don't really have any problems. And that doesn't really tie in with your ARD system that much. Other than, say it was stuck open somehow, and it was dumping pure EGR into that engine, well, then you'd have a lot of associated problems. But what we're going to be talking about is your secondary air and your turbocharger. So on a C15 or C13, you're not going to have test points 5 and 6 because it doesn't have a variable geometry turbo, and that's what test points 5 and 6 are testing. The ones that really matter are test points 3 and 4 on C7, C9, C13, C15. Test points 3 and 4 are the ones that matter. So first things you need to look at is boost pressure. Do you have boost pressure? Boost pressure is going to be slightly higher on a C7 and a C9 because they have variable geometry turbos. So the engine can produce more boost at lower engine loads. On a C13 or C15, you might see down to 1.5 psi of boost pressure during this test, and that's okay. It's nice to see higher, but if you only see that much, your system should still work. Now, if you start seeing 1 psi or less, you might not have enough pressure to push air into that ARD head to complete combustion. So test point 3 is with the CGI system, or not the CGI system, with the secondary air system closed. So the valve is closed, and your max flow should be, typically it's around 25. You can see there the min-max between 19 and 36. It's always something. It's always going to be around 25 or so, even though no flow is going there. Now, test point 4 is when the valve opens. So when the valve opens, you're going to lose a little boost. You want to see a small decrease in boost pressure, and you want to see that secondary air mass flows increase a lot. So you normally want to see it around 200 to maybe 300 on the larger engines. you know, if it's only showing 100 or 120, or it doesn't move at all, then you have a problem with your secondary air system. And if you have a problem with your secondary air system, you're not going to have proper combustion. So, on that, does the numbers change? If they do, and they're within the min-max, you're pretty much set. You know your secondary air system is working properly. Okay, so before we move past the secondary air circuit, if your system isn't regenning and the art head's good, the second biggest cause of a regen problem is the secondary air circuit. And by circuit, I mean the tubes and valves that control it. Now, the valve very rarely fails. I may have replaced one or two. It's usually, if say that test point 4 number is really low, or say it's really high, like, oh, it's higher than normal, it's at 1,000. Well, then there's usually a crack in the lines going to the sensor for the secondary air mass flow. And really check that sensor. Make sure the sensor's not cracked. You know, make sure it has the wiring is tight and the connector's tight going to it. That's a real common failure point. Also, remember that the secondary air needs boost pressure. If you don't have any boost, you're not going to be able to push air into that art head. Also, the secondary air needs your boost pressure to be higher than the Dpf differential pressure. So if you had 2 pounds of boost, but your differential pressure is at 1.8 psi, which would be very high. If it was that high during a regen, you probably need to get that Dpf clean. But theoretically, if you had 2 pounds of boost and 1.8 psi differential pressure, you would only be able to push with 0.2 psi of pressure, because your boost and your differential pressure are almost the same. You have to remember that. You always need your Dpf differential pressure to be at least a psi lower than your boost pressure, or else you're not going to get any secondary air in there. So let's say you do your secondary air test, you have 0 boost. Well, then you have a problem not with the regen system. You have a problem with the engine and the engine air system. So you could have a bad turbo, you could have leaking CAC, a plugged CAC, something like that. If you're really low on boost, it's not going to regen. And if it's low on boost, you need to get that fixed before you go throwing an art head on this thing. Once your boost is up, then you can try the regen again. Okay? That's going to cover the secondary air portion and the mindset behind it. Okay? Moving on. Okay, so we're back on CAD-ET, and I had put a new art head on this engine that we were data logging before. And the reason I did that is we looked at the pilot pressure. It was good. It was at 100 pounds during ignition. I did a secondary air test. It was good. It had good boost. Our Dpf differential pressure was good. I checked all the temperature sensors. They were all okay. So I had put a new art head on this. Now we're going to see if it ignites and if it does a good regen after putting the new art head on. And so I've already done the data log setup. I'm not going to show you how to do that again. And what we're doing is we're waiting on pending checks, and then it's going to go to art ignition again. So same engine. This is after putting a new art head on it. And like I said before, about 80% of the regen problems, typically it's an art head. So we're in our pending checks. Once it goes check mark, okay, so now we're in art ignition. Check and watch your flame temperature. It should spike very quickly. Okay, so it's up to 230, 290, 400, 600. So this is doing a successful regen. This is what it should look like during the regen. Now I'm going to be going over the graphs in more detail on another engine that was having a regen problem. Okay, so I put an art head on that engine and it fixed it. It did a successful regen after that. And now I didn't show you a lot of the data log stuff because I'm going to be showing you it on this next one I'm going to be doing. But this one I'll be going over in paper graphs, so it'll be easier to see than where I'm trying to hold the camera and take little screenshots in CAD-ET. But these are from CAD-ET. And I'm going to be talking about what the numbers mean in more detail. So while it's regenning or trying to do a regen attempt and you suspect it's going to fail or it does fail, how it fails can tell you what the problem is. So if it's a failure to ignite, that could tell you there's a problem in the spark circuit or the air or the arc head. The arc head is always a likely cause, but certain things will kind of negate or kind of eliminate potential causes. So we had a loss of combustion there, which means it did ignite and then loss of combustion. So we know that it's not in the spark circuit because once that arc head lights, it should stay lit. And it did light and then it died off. So kind of eliminate the spark system on that one. It still could potentially have been a secondary air problem, but we did a secondary air test and that looked okay. Typically loss of combustion though, going to be your arc head. So what are the other common failures while it's doing a regen that'll kick it out? So the other things that will kick it out is failure to ignite. That's where it, during the ignition attempt, it never ignites. It doesn't ignite at all. If it doesn't ignite at all, well then, that could be just about anything. Okay, so that's when you need to make sure during the ignition attempt it has 100 pounds of pilot fuel pressure and 100 pounds of secondary air pressure. Now, if it does have that and it still won't ignite, you need to check your spark system. Is it sparking? Which I already showed you how to check. If it's sparking and you have 100 pounds of air, 100 pounds of fuel, probably arc head. But check, does it have really high differential pressure? Are your sensors reading correctly? Is one way out of whack? If you have one sensor, temp sensor way out of whack, you need to fix that first because that can throw it off. Because it uses the temp sensor and the hard outlet temperature and Dpf inlet temperature to monitor if it's igniting. So what are the other codes that typically come up during a regen if it fails? Well, low Dpf inlet temperature. Remember, your Dpf needs to get to almost 1100 degrees in order to perform a successful regen. And the one I'm going to be showing you next, it wasn't getting to that 1100 degrees. And I'm going to go over what I did to fix it and how I troubleshot it. Okay, so here we have a data log graph of a C7 that was not successfully regenning. It would ignite, but the Dpf inlet temperature was only getting up to about 900 degrees, so that is not hot enough. You need almost 1100 degrees. So what we look at here is during the pending check, it opens the secondary air valve, and you had about 270 pounds of secondary air. So that's good. It fully opens pretty much. And then after that, it's sitting around 100, which is okay because the ECM controls the amount of air after that point. Now your pilot pressure, also at 100 during the ignition phase. So you can tell it's igniting because if you look at the greenish line, that's your Dpf inlet temperature. That immediately rises when your pilot pressure comes on. So we know it ignites. And what you need to look at after that point is that your inlet temperature to the Dpf was only 900 degrees, not hot enough. Now look at your pilot pressure. It is maxed out. It's around 250 psi, which means your pilot pressure circuit's good. It's building enough pressure. And it's maxed out. So the ECM's giving all the fuel it can to that arc head, but the Dpf inlet temperature is not hot enough. Now when you see this, where your pilot fuel pressure is maxed out, but your Dpf inlet temperature is not hot enough, that is almost always an arc head. Now it could potentially be something wrong with the Dpf differential pressure, but I'm going to be showing you a graph that will show that as well. So normally when you see pilot pressure maxed out and your pilot pressure is at a good pressure, mid to high 200 psi's, then usually it's an arc head. So here's another graph of the same regen attempt. So what I'm doing here is looking at your Dpf in and out temperature to make sure they both correspond, which they do. And your outlet temperature is always going to lag behind inlet because it takes a while for the heat to get through the Dpf, but they're in parity, so they're good. Next, we're looking at Dpf differential pressure. Now, it's only at 0.3, which is very good. So differential pressure is good. And then the bottom line here is main pressure. Now remember what I said about main pressure. It's basically a functionless circuit. If it's coming on, that's because there's a problem. Now it's not coming on here, but your pilot pressure was maxed out. So what I did is I checked for spark, which we knew we had because we had ignition, just not burning hot enough. Secondary air test, everything looked good. Changed the art head. It looked like it needed an art head, so put the art head on. So here we are. We have good secondary air. It's running around 100 again. This is during a regen. That's good. So, which it was good before on the regen, so there's no reason that should change. Now look at your Dpf inlet temperature. It is almost at 1100 degrees, which is good. But your pilot pressure is not maxed out. It's sitting around 160 psi or so. So it still has almost 90 psi of pressure to apply if it wanted to, but it doesn't need to. So it's hitting it with 160 psi, and your Dpf in temp is at 1100 almost. I'd like to talk about the difference between soot load and ash load as well. If you're getting a high soot load, that means that's normal, and your Dpf needs a regen to clear it. If you're getting a high ash load, that is different. Ash is unburned oil or soot that's been cooked and turned into ash, and over time that will fill up your Dpf. You cannot cook ash. If you get a high ash load code, the Dpf needs to be removed and cleaned, and then after it's cleaned you can go into configuration and reset your Dpf ash load. And that's in the bottom of configuration. It'll say Dpf regeneration ash load reset. And you can click reset. It'll ask for the Dpf serial number and factory passwords. At that point, it will think that you cleared out the ash, which you should have. You should have removed the Dpf, had it cleaned. If it's damaged, have it replaced. And that's the difference between ash load and soot load. Alright, so the last ET clip I'm going to be showing you is your heater nozzle circuit test. So if you go into diagnostics, system troubleshooting settings, there's something called the fuel nozzle heater electric circuit. And if your engine's running, you can turn this on. And what this does is make sure that the nozzle heater on your C13 and C15 engines is working. And the way you test it is you turn that circuit on in ET, and then what you're going to do is put a amp clamp on that center line going to the head. And it should pull about 7 or 8 amps. So this is pulling just under 8 amps, so we know that the heater nozzle circuit is working. Okay, so that's really the meat of this class. Now I wanted to have some parting thoughts. This section will be me talking about some other things to look for in your regen systems. So when the system does a successful regen, it logs a 310, a 310 code. If you see 310-0, 310-1, 310-2, there's no description of what that is, but that is a successful regen. So if you have those in your system, that's telling you that the system has done successful regens. It'll also tell you the last successful one, which is good to know at times. Also, there are fuel filter fittings in the regen system. Now you might ask, what is a fuel filter fitting? Well, the lines, the main and the pilot line running to your art head come off a small manifold, where the coolant lines and the fuel lines come off of. The fittings on that manifold for the fuel lines are not normal fittings. They are filter fittings, which means they have a screen in them which is supposed to prevent debris getting into the art head. So let's say you change the art head, the pilot pressure is still building, but it doesn't seem like any fuel is getting to the art head. That could be the plugged fuel filter fitting. They're fairly inexpensive, and it's a good idea to change them if they've never been changed on your engine. But the fuel going to the art head is typically very clean, and I've yet to see a filter fitting plug and cause a problem. But I've heard of people say that, oh, I changed the filter fittings and it fixed them. That's just something to be cognizant of and check if you're getting issues. with your art head repeatedly. Also, the check engine codes you can get to your art head. There's endless amounts of different check engine codes that can cause regen problems. Anything with a EGT temp sensor, that's pretty much going to lock you out from doing regen. So if you have a code with that, you need to get that addressed. Also, the codes for your art head system, like the soot load codes. If you have a Dpf soot load, you can't clear that code. You have to do a regen, and then it will clear by itself. Now, the codes that will lock you out are permanent lockout, which means it's done a lot of regen attempts but hasn't ignited. You can clear that with factory passwords. It's not permanent. Failure to ignite. That will, after a few attempts, if it doesn't ignite, it will give you a hard code where it will not allow it to try a regen attempt again. Same with loss of combustion, which I showed you in the video. If it gets that code, you're going to have to clear it with factory passwords. Those are really just the ending points of this class that I wanted to address. Now, there's endless amounts of different questions you may have, or questions I haven't even thought of that you may have. You can leave them in the comments section, and I'll address them as quickly as possible. I usually get back to comments under an hour, pretty much any time of day. Unless it's late at night, obviously, I'll be asleep. Also, you can email me if you have a specific concern. If you're having one that's you're having a lot of issues with, I have a Skype account. Email me if you want to Skype with me. I usually charge a little bit for a Skype consultation, but you can talk to me, face to face over Skype, and if you're having an issue, I can address it with you. That's really the end of the class. I hope you learned a lot. I try to pretty much say everything I could think of about these regen systems and go over the component identification. If you have, like I said, if you have any questions, leave them in the comment section. And I thank you for watching this class, and hope you have success with troubleshooting these systems. All right, thank you.